The word Kubernetes is Greek for helmsman, the person who steers a boat. But over the past few years, the word Kubernetes has become nearly synonymous with containers, and particularly container administration. Without a doubt, Docker is no longer the first name most people think of when the term containers comes up in conversation. But that doesn't mean Kubernetes has in any way replaced Docker. In fact, Kubernetes can run on top of Docker Engine. So then just what is it that Kubernetes can replace? That would be Docker Swarm, which we saw in action a bit earlier. Kubernetes itself, to repeat what you probably already know, was originally developed within Google to efficiently manage the billions of containers called into existence daily by the world's internet search requests and Gmail sessions. Handling containers at that mind-bending scale involves more than just launch it and forget it. Such deployments require immensely sophisticated automation, integration, coordination, and operational visibility. So it's fair to say that Kubernetes has been well tested in the real world. Some years back, Google handed the Kubernetes project over to the Cloud Native Computing Foundation, and they've been managing it ever since. It's also undeniable that while Docker Swarm is certainly a mature technology, Kubernetes has a much more active support and development community behind it. Now practically, how does Kubernetes stack up against Docker Swarm? Anyone who's used both will tell you that Kubernetes has a much steeper learning curve. Building work environments is more complicated, and getting your mind around the terminology and many infrastructure elements can be difficult. While Kubernetes can handle any Docker container you send it, it's not compatible with Docker Compose scripts. One more difference. Unlike Docker Swarm, which can run at least one node on any OS, the Kubernetes control plane can only run on a Linux or macOS host. That's the relatively bad news, but working through all the stuff that Kubernetes does exceptionally well will take a bit longer. Scalability, high availability, and load balancing, for one thing, well, three things, are built into Kubernetes and in many senses automated. Kubernetes also features mature, self-healing failover and rollback management. Kubernetes security employs RBAC-based authorization and authentication, where RBAC stands for Role-Based Access Control, integrated secrets management, and security policies at both the pod and network levels. Finally, while we've seen Docker's relatively recent Docker desktop product, Kubernetes has had a built-in and tightly integrated dashboard for as long as I can remember. We've got three primary goals for the remaining lessons of this course. The first involves a high-level survey of the key elements that go into a successful Kubernetes deployment. That should help you visualize how the infrastructure works. The second goal will see us explore the range of environments we can use to host our Kubernetes container workloads. And we'll wrap things up with a quick demo of some surprisingly simple tools for launching some surprisingly sophisticated applications. Let's not push this off a moment longer.